A dust storm rolls across the horizon. The air is a pale, swirling haze, each breath a test of endurance. Through the shifting veil, shapes emerge. Small, low to the ground, moving in deliberate unison. Their silhouettes are strange, heads bowed beneath the wind, each profile marked by a swollen curve that breaks the symmetry of the face. In this place, survival is a negotiation between body and climate, and here, every breath matters. The travelers push forward, not with speed but with purpose, covering miles of open steppe as the storm rages around them. The sound is only wind and the muffled rhythm of hooves. Their faces are hidden in plain sight, carrying an ancient design that shields them from what the desert can take in seconds. It is not beauty. It is not elegance. It is something older, something shaped by extremes. And without it, the journey would end here, in the dust. The steppes of Central Asia are a theater of harsh contrasts. Summers bring searing heat and storms of grit that scour the land. Winters drop into lethal cold, each breath turning to ice before it reaches the lungs. Few large mammals can endure both. But one antelope has persisted here for tens of thousands of years, riding the shifting seasons with a toolkit that seems improbable. The Saiga antelope's most distinctive feature, its oversized trunk-like nose, is not an evolutionary accident. This organ is a masterwork of adaptation, an all-weather filtration system that transforms unbreathable air into life. In summer, it traps dust and debris carried by the wind, preventing the lungs from clogging with grit. In winter, it warms and moistens frozen air, shielding delicate tissue from ice burn. This single structure allows the saiga to survive migrations that stretch hundreds of kilometers, from open steppe to semi-desert, crossing terrains where the air itself can become an enemy. Fossil evidence suggests that the saiga's lineage reaches back to the Pleistocene, when vast herds roamed from the British Isles to Alaska. Back then, it was not a rare sight, but a widespread grazer, a keystone species shaping entire landscapes. Its survival was tied to its mobility, migrating in vast columns to track fleeting patches of grass across a frozen or scorched world. But where other antelopes evolved speed, the saiga's greatest advantage was endurance. Its nose became a multi-season survival tool, a trait refined by millennia of wind, dust, and frost. Today, that adaptation remains intact, even as the herds that once numbered in millions have dwindled to tens of thousands. And yet, this nose is more than just a filter. Inside its soft, bulbous structure lies a labyrinth of cartilage and mucous membranes arranged to maximize surface area. Air entering the nostrils is forced through a maze of folds, where dust is trapped and ice is melted before the air flows deeper. This process is so efficient that a saiga can breathe through sandstorms without slowing its pace. It is an elegant answer to the central paradox of the steppe, the need to move quickly through environments that strip the body with every breath. But such perfection raises a deeper question. How did one structure come to perform so many critical roles without compromise? Filters slow air, warmers require energy, and yet the saiga's nasal system manages both, seamlessly in the midst of constant motion. This is the puzzle. How did evolution condense filtration, thermal regulation, and respiratory protection into such a compact, efficient form? In most animals, specialized adaptations come at the cost of versatility. The camel's nostrils are excellent at moisture retention, but do little for dust filtration in high-speed migration. The reindeer's nasal passages warm freezing air, but cannot block fine particulate matter. The saiga's nose, somehow, does all of these at once, without apparent trade-off. And its design has withstood the test of time. Across ice ages, droughts, and sudden climate shifts, the saiga has kept its signature face, even as countless other steppe species vanished. Scientists have proposed several possibilities. One theory suggests that the saiga's nose evolved primarily as a dust filter during the dry, windy summers of Central Asia, with its cold weather benefits emerging later as a secondary advantage. Under this model, the species' survival in winter would have been a fortunate byproduct of an adaptation meant for summer endurance. Another hypothesis points to the pressures of migration itself. Moving hundreds of kilometers in tightly packed herds kicks up enormous clouds of dust, meaning the threat comes not only from the environment, but from the herd's own passage. In this case, the nose would have evolved as an internal shield against the very act of survival. A third view considers the saiga's nasal structure as an integrated climate regulator, a system that may also play a role in controlling body temperature during sustained movement, helping the animal maintain stamina in both heat and cold. Each theory explains part of the picture, but none fully accounts for the apparent perfection of the design. Field studies are rare, in part because the saiga is now critically endangered. Poaching for horns, disease outbreaks, and habitat loss have brought populations to the brink more than once in the past century. In 2015, a sudden bacterial infection wiped out over half of the global population in a matter of weeks, a collapse so fast it left conservationists stunned. The species has rebounded since, but its future is still uncertain. Against this backdrop, its nose becomes not just a survival tool, but a symbol, a reminder that even the most refined adaptations cannot shield a species from threats beyond the environment it evolved for. Some researchers hope that by studying the saiga's nasal mechanics, we might uncover designs applicable to human engineering. Respirators that filter fine dust without reducing airflow, or cold weather breathing systems for extreme climates. Others see in it a cautionary tale, that evolutionary success in one arena does not guarantee safety in another. For the saiga, the danger no longer comes only from sandstorms or freezing winds, but from human expansion and the fragility of migration routes in a changing world. The image remains, a line of shapes moving through a storm, heads bent, nostrils filtering the air as they have for millennia. Every breath is cleaned, warmed, and sent into lungs built for endurance. The design is quiet, understated, almost strange to the eye. But without it, there is no journey, no survival, no future for the species. It is a reminder that sometimes the most important tools are the ones hidden in plain sight, overlooked until the moment they are needed most. So the question lingers. In a world where climates shift faster than evolution can respond, can one strange nose still mean the difference between life and extinction? Or will the desert's perfect filter outlive the land and the herds it was made for, becoming just another vanished solution to a problem no one remembers how to solve?